Hey guys, okay, so we're going to be starting off these lessons that you guys are going to be working on Alex, but first thing we got to do is make sure you guys understand what you're supposed to be doing because all of these lessons are going to be brand new to you. So what we're going to do for this is talk about excluded values for rational expressions and also how to simplify them. So let's start off with the idea of excluded values. So first off, excluded values. Now, excluded values are numbers that cannot be used in an expression. Now, the reason why they can't be used is usually, in our case, because of the fact that we're going to end up dividing by 0. So I'll put this right here. They will make a division by 0. Okay, and you guys know that we can't divide by 0, so since we can't ever divide by 0, we got to figure out what numbers make this rational expression, this fractional expression, something that makes it divided by 0. So let me give you some examples here. So let's see. We'll do example number 1. And for example 1, it's I'll put right here, find the excluded values. Find the excluded values. And we'll start with part A here. So 2x over 3x minus 6. Now, when they ask you to find the excluded values, what they're basically saying is what makes the denominator, equal to 0. Because whatever makes the denominator equal to 0, those are the numbers we cannot use. So what we're going to do is we're not going to worry about the numerator. Who cares about the numerator right now? We're just going to look at the denominator. And we're going to write 3x minus 6 equal to 0. So what we're going to do it now is just solve for x. So we'll add 6 to both sides. And we get 3x equal to 6. Divide both sides by 3, so we get x equal to 2. So if x is equal to 2, the denominator becomes 0. So then for us, we don't want x equal to 2. So what I'm going to say is x cannot equal to 2. And that's going to be my excluded value for that problem. Okay, because if x equals 2, then we end up with division by 0. Just so I can show you this really quick, if I plug in a 2 into the problem, it becomes 2 times 2 over 3 times 2 minus 6. That's 4 over 6 minus 6, which is 4 over 0. That's a problem. So we don't want to have that happening. Okay, so for excluded values, we don't want this to happen. Okay, no division by 0. So let's try another example here. So part B here, we have x plus 4 over x squared plus 2x minus 8. Now, if you notice, for the top expression, all I did was I got the denominator and set it equal to 0. That's the same thing I'm going to do right now for the expression I have here. Okay, so all I'm going to do is I'm going to get the denominator, which is x squared plus 2x minus 8, and I'm going to set it equal to 0. So in order to do that, I may have to actually factor by using the x method. So let's try doing that, okay? So we'll set this up here. Remember, in order to get the number on top of that x, we multiply these numbers here. So I know it's not there, but there's a 1 there and a negative 8. Okay, so 1 times negative 8, that's going to give me a negative 8. And then on the bottom, we get our b value. So this is our b value, okay? This plus 2, that's going to go down towards the bottom. So there's 2 right here. So two numbers that multiply to a negative 8 but add up to a positive 2, that would be a positive 4 and a negative 2. These are my factors. So I'm just going to write x plus 4, x minus 2 equal to 0. Now you can set each piece equal to 0. So x plus 4 equal to 0, x minus 2 equal to 0, and you solve. So this is x equal to negative 4, x equal to a positive 2. So remember, those values, negative 4 and 2, those are the numbers that make it equal to 0. Remember, we do not want it to become 0. So what I'm going to do is write x cannot equal to negative 4 or 2. Okay, so that's going to be my solution to this problem. Now later on they're going to ask us to simplify stuff like this, and we'll do that because we would be able to cancel some stuff out, but still our excluded values have been found. Now the next part of your lesson for this day is they're going to want you to be able to simplify these functions. Okay, so let me start you off with something with just simplification. So we're not going to do excluded values anymore. Okay, sometimes they might ask you for both. They might say simplify and find the excluded values, or sometimes they just might say find the excluded values, or they might just say simplify. Okay, and when you guys are simplifying, you're going to have to factor as much as possible, unless they already factored it for us, which I'll show you one in a bit that's kind of like that. But if they just want us to simplify, then we're going to get what's given and try to simplify as much as we can. Plus 6y minus 7. Now notice I'm not asking you to find any excluded values or anything like that. We just want to simplify everything as much as possible. Now, the top is already simplified as much as possible. Okay, so this is just y minus 1. But the bottom can be simplified. So what I'm going to do is I'm going to do that over here on the right side. I'm going to do the x method. And I'm going to multiply this 1 here times a negative 7. That's a negative 7. And then the plus 6 goes on the bottom. So two numbers that multiply to negative 7 and end up at plus 6 would be a positive 7 and a negative 1. So I'm going to write y plus 7, y minus 1. Now at this point, I notice that this right here and this right here, they match. So that means that I'm able to cancel them out. So I'll cancel them out, and all that's left is 1 over y plus 7. And that would be my solution to this problem. Okay, so you can cancel things out that match up. Okay, now I told you guys earlier that sometimes they'll give you stuff that's already pre-factored. So here's an example of one that's going to look like really tough. But if you pay close attention, you're going to notice it's already all pre-factored for you. You're not going to have to do any factoring, but you are going to have to try to find things that match up. So here is the whole problem written out. Okay, so they want us to simplify this. So we are going to basically do what we need to do. We're going to have to try to simplify as much as possible. So let's do that. Okay, so let's see. This 14 and this 7 can reduce. This will become a 2. This will become a 1. Okay, and then I also notice that there's two x minus 2's here. Okay, there's two x minus 2's, but one of them has a power of 2 and the other one has a power of 1. I know you don't see it, but it is there. Okay, so in canceling those things out, I can cancel 1x minus 2. And remember, this one right here has 2 of them, right? It's like x minus 2, x minus 2. So I get rid of one of them. Okay, so the way we kind of denote that is we get rid of this and we put 1 instead. Okay, now for the last part, the 2x plus 1s, notice on top there's a 2x plus 1. Over here there's a 2x plus 1, but the one on the bottom has 4 2x plus 1s. Okay, the one on the top only has one of them. So when we cancel that out, that's going to get rid of only 1. So that means I end up with the power of 3. Now, based on what I have left over, I still have a 2 up there, so I'll put a 2. I don't have any more 2x plus 1. I do have an x minus 2 left over. On the bottom, I have a 1, so I'm not going to write it yet. And then what's left over is a 2x plus 1 to the third. Now, you could put that 1 there, but it just looks a little odd, so I would just erase it just to get rid of it. And that would be my final solution for something like this. Okay, now I know some people don't like to do the work this way, so I will show you a different way. And you might say, oh my gosh, this different way looks way different. But I mean, if you like it, go ahead and try it. So let me show you a different way. What I'm going to do is I'm going to expand this. So 2x plus 1, and then we had a x minus 2 squared, so it's x minus 2. And then on the bottom, we're going to have a 7, and then x minus 2. And then it was 2x plus 1 to the fourth, so 2x plus 1, 2x plus 1, 2x plus 1, 2x plus 1. Now, what I'm doing is just expanding it totally. Okay, now at this point I will cancel out what they have in common: an x minus 2 with an x minus 2, a 2x plus 1 with a 2x plus 1. Notice you can see that we're done canceling what they have in common, except for this piece here. This should be a 2, this should be a 1. So your answer should be a 2 times x minus 2. That's what's left over on top. On the bottom, there's a 1, but then there's 3 2x plus 1, so 2x plus 1 cubed. Notice we get the same exact answer. Yes, it took us a little bit longer, but maybe that's better for you. So you decide however you'd prefer to do the work, but you know, it should work either way. Okay? Now, let's try doing another one here. You have, let's say, 3w squared minus 9w over 2w squared minus 6w. Now, what I'm going to do is I'm going to take out the greatest common factors first. So I notice that on the top, you can factor out a 3w. On the bottom, I notice I can factor out a 2w. Okay, from both those terms. So let's see. If I factor out a 3w from the top, I'm left with the w minus 3. And if I take out a 2w from the bottom, I have a w minus 3. Now notice how they have matching terms, right? So w minus 3 is going to cancel out. These w's will cancel out. So my answer is 3/2. And that would be my simplified form. Okay, so remember, for that one, I had to start by taking out the GCF, the greatest common factor. All right, D. By the way, for those of you guys that don't know me and the way I teach, I usually do a lot of examples. I want you guys to have many things that you see. That way, you don't feel like you didn't see enough examples, and then you're left kind of thinking like, man, I wish I would have seen one that looked similar to the following problem or something like that. So I do give a lot of examples, but we just have 2 more, okay? I'm just giving you a little bit of everything so that when you guys do this homework, you at least have seen everything required. Now, on the top, we are going to factor. On the bottom, we're going to factor. We're going to have to use the x method for both of them, okay? So let's start off with the x squared plus 2x plus 1 portion, okay? So we're going to do an x method for that one. And for that one, we're going to get 1 times 1, that's a 1, and the 2 goes here. So these would have to be positive 1s on both. So this would be x plus 1 times x plus 1. Now, let's do this one here. Okay, we're going to do the x method here. 1 times 3 is 3. On the bottom, it's a 4. So the numbers that multiply to 3 and add to 4 are 3 and 1. So we're going to have x plus 3, x plus 1. Now, if they would have asked you in this problem to find the excluded values, then you would focus on just the denominators, okay? You're going to set x plus 3 times x plus 1 equal to 0 and solve for them, okay? So the answers would have come out to -3 and -1. So you would say x can't be -3, x can't be -1. But I'm not asking you for that, okay? We just want you guys to simplify. So in this case, let's do that. If you look, I have matching x plus 1s here and there. Other than that, nothing else is the same. So I can just write x plus 1 over x plus 3. Now, I do sometimes get people that say, well, Mr. B, they have an x in common here and here. Why don't you cancel that out? The reason why I cannot cancel those out is because they are stuck together by the mathematical operation of plus. This plus is like glue. You can't just take one piece from it. You can't chip away at it. If you're going to cancel it, you need to cancel everything that it has in common. Just like over here, we canceled out the full x plus 1 on top and on bottom. So you have to get rid of everything, not just the plus, not just the 1, not just the x. Everything has to be able to get canceled, okay? So, all right, last example. Example number 3. Now, this is going to be kind of like putting everything together. Simplify and find the excluded values. Now remember, this has a lot to do with factoring this lesson, so we're hoping you guys remember how to do that. If not, you look through your notes and find that stuff. But you guys have to make sure you remember your factoring, okay? So 16 minus 4x squared over x squared plus x minus 20. Now, some of you guys might be looking at the top part saying, oh, that's a difference of 2 squares. And you would be right. Okay, but first we take out everything that they have in common. So they have a 4 in common on top. This would be a 4 minus x squared. Okay, and then on the bottom, well, if you look, it's x squared plus x minus 20. Let's go ahead and put that into an x method, okay? So 1 times -20 is -20, and we drop the 1 here. So this would be a positive 4 and a -5. Okay, so a positive 4 and a -5. So this would be x plus 4, x minus 5. Now, we can still factor this top part right here. Okay, this is called a difference of 2 squares. We can still factor it. There's a little formula that you use, which basically says if you have a squared minus b squared, then you write it a minus b times a plus b. So I'm just going to write my answer like that. This is 2 minus x, 2 plus x over x plus 4 times x minus 5. Now, I do want you guys to notice we still haven't found our excluded values, but I just wanted to factor everything first. I'm not going to cancel anything yet, if possible, but I am going to look at this denominator here. Okay, in order to find my excluded values, I got to find the denominators, sorry, not the denominators, I got to find the answers to the denominator if I set it equal to 0. So here we go. Let's set that equal to 0. X plus 4 times x minus 5 equal to 0. That means that x plus 4 equals 0 or x minus 5 equals to 0. So x is -4 or x is +5. So my excluded values are that x cannot be -4, or +5. Okay, those are my excluded values. That's part of my answer. Okay, the rest of my answer is actually pretty much done. Okay, notice they wanted me to simplify and cancel. There is nothing I can cancel in this problem. Okay, so I'm just gonna write my answer like that. So hopefully this helps. If not, please contact your teachers, talk to them, let them know that you're having trouble so that we can help you guys out. Remember, we will have some office hours during certain times and certain days. So please contact us, guys. Don't just let it go. All right. Hope you guys have a good day.